Here we go, differentiating using multiple rules. So there's several layers here, and then we just have to do our best to keep track of what we're doing. And I would really recommend using your cheat sheet at this time because we're using all the different rules that we've kind of talked about. So if you don't have them memorized, using that cheat sheet will really help. Of course, if cheat sheets are not an option, then you're stuck having to memorize all the rules. So let's go ahead and take a look at it. So when we look at this one, we're doing the derivative, and notice there are 3 x functions going on. So we kind of saw one of these earlier in the strategy idea of grouping them together and doing the derivatives in that way. So which way would I do it? Let's see. Sine and cosine. Oh man, getting those trig functions involved. I'll just go ahead and do x to the 4th times sine x, and I'll group those. Not sure if this is the easier or harder way, but it's not coming out at me. So we'll go ahead and do it that way. So this is the product rule, where this is one product times the second one. All right, the derivative of the first. All right, so I would recommend just doing this on the side, d dx of x to the 4th times sine x. All right, so I'll go ahead and do this one as side work, and then that way I can plug in the derivative of the first times the second and go for it from there. All right, so how would we do this derivative? Once again, derivative of the first would be 4x cubed times the second, sine x, plus derivative of the second would be cosine x times the first, x to the 4th. All right, so there's our, that wasn't too bad. But notice I definitely wouldn't try layering this in my head. It's a lot of layers already. All right, so the derivative of the first is this. So that'd be 4x cubed sine x plus cosine x. I probably should have put that x4 right there. That'd been easier. That's fine. So the derivative of the first times the second plus derivative of the second, which would be negative sine, times the first, x to the 4th sine x. All right. And good thing we're not using any trig identities. This is hard enough already. All right, so what do we got going on here to simplify? It's looking like it's going to be something like this one here, but let's just go ahead and confirm. All right, I'm going to go ahead and let's do pink. So it looks like they're distributing the cosine x right here to those two. So that would be 4x cubed sine x cosine x. Should have gave myself some more room. Plus cosine, they're both cosine x's, so cosine squared x, x to the 4th. Probably should have put that x to the 4th in front. There's the plus, that plus turns into a minus from that one. Minus sine x and sine x. I'll move that x to the 4th, and we got sine squared x. All right, so that looks pretty good. Let's see, is that what we got here? 4x cubed sine x cosine x, check. X cosine squared, x4 cosine squared x, yep. Minus x4 sine, yep, there we go. So that was layering. Let's check out the next one. All right, we got a quotient rule here, and we got cosecant. All right, so I don't have cosecant memorized, but I do have my cheat sheet right in front of me. So the derivative of cosecant, so this is always good to practice, so I'm going to look at it. Negative, so it's in terms of either cosecant, cotangent, or in terms of cosine and sine. When I look here, notice everything is in terms of cosecant, cotangent. So it's negative cosecant, cotangent. So the derivative of cosecant of 3x would be, and that would be negative cosecant, CSC 3x cotangent of 3x. Let me just confirm I did it right. negative cosecant, cotangent. Yes. And then we have a layered here. There's a 3x in here. So all of that would be times 3. And I just want to put it, usually I'd put it in front. Having it at the end is just how the chain rule works. All right, so there's the side work for the derivative of the top. All right, and we got the bottom here to deal with. So that would be quotient rule. So this would be derivative of the top, which is this. I'll move the 3 out in front. Negative 3 cosecant 3x. That's a s. Cotangent 3x. The derivative of the top times the bottom minus the derivative of the bottom, which is just 3x squared, times the top. All over the bottom squared, which is x cubed squared. So that's the quotient rule. And we had an option. If we wanted to manipulate it and throw this into the top as x to the negative 3, we could have done that and used the product rule if you forgot the quotient rule. But since we're practicing our methods here, let's just use the method that they gave us. All right, and let's see. Well, there's not really much rewriting to do here. Let's be careful, see if they okay, so that's where these two right here are, it looks like there's some factoring that went on. So they factored out the cosecant and the 3. So let's go ahead and do that. There's a negative 3 and negative 3 here. So there's a negative 3x squared, negative x cubed here, x squared here. So negative 3x squared, those might reduce out. And we have a cosecant 3x and a cosecant 3x. Cosecant 3x. So all of that got factored out. So what's left? We got the, what's that? Cost? No, that's no good. That's just a cotangent. Cotangent. That's okay. That's better. Cotangent. Cotangent. There we go. So I pulled out the negative 3 x squared cosecant 3x. That leaves a cotangent 3x, and there's still one of these x's left there. So I'll put it right there. Should be out in front to be less confusing, but that's fine. I pulled out the negative, so that means this is now a plus. And the 3x squared got pulled out. The cosecant 3x got pulled out. That leaves just 1. Everything got pulled out. And on the bottom is x to the 6th. And I bet a lot of students would really want to pick that x to the 6th right away. But we got some reducing that we could do. So x squared goes into 2 of these, leaving 4 left, x to the 4th. So negative 3 cosecant x 3x. Negative 3 cosecant 3x, check, factored out. X cotangent 3x, x cotangent 3x plus 1, check. X to the 4th, check. So on this one, it was doing the side work for any derivatives that kind of are embedded inside of your function. And then in this sense, it's a good thing they had multiple answers to choose from, because the derivative of cosecant had 2 different versions we can use. So we needed to use the one that's interpreted with the answers that they have. So that's the reason why I used this version here. And then we needed to factor things out so it matches. And I could pretty much tell that from there's no plus signs or minus signs, which these have. So it had to be one of these 2. Then we just want to make sure we do all of our work properly. Okay. All of them seem to be kind of the same style, where it's layered and you might have to layer it. This one looks a little bit easier. with the layering. All right, good luck.